Good morning all together. My name is Thomas Bremer. I'm from Germany. I'm a software developer I'm working as a freelancer, mainly in the area of embedded systems and geoscience or geospatial science is kind of my hobby, which on the one hand gives me lots of fun, entertainment, hopefully useful results, but I don't have much time for it. And with this thing I'm going to present here, I've hit some in some big bubble which might explode at some time. So he's not the AV guy? Huh? Okay.
You can recognize them by just selling t-shirts.
Yeah, okay, I expected that. Yeah.
This one in past.
Yeah.
Or something like this.
So you added the camouflage. Yeah, well, for the remainder I need the slides. Well, the first slide I can start. I can try to start my presentation without the slides because the first stuff I can simply tell you. I started with a presentation or the idea of Thomas Alva Edison, who, well, rumor has it that he has invented the light bulb, which isn't true. He hasn't done it. It was a German called Heinrich Goebel, and Edison made it usable for the public, this light bulb, and this screw mount, which you know, or which maybe the elder people of you know from when we had this incandescent light bulbs to plug or to screw in. They have different sizes, E10, E14, E27, and this E stands for Edison, so that's where his name has remained until today. But he's also famous for certain quotes he made, and one of this is, genius is 1% inspirations and 99% perspiration. This also holds for me because I'm more on the 1% side, I have to say. And last year I've been here and there was a talk about this web server 3geonames.org. I have to correct the slides. I see there are some typos on them. This web server had the feature that you give it some geo coordinates interactively by clicking, or it also had an API, and you get back a combination of three city names worldwide, which represent this location. It's not a kind of compression, but it's kind of a mental compression because you three words with a meaning, or you maybe know them, they're more easily to remember than two long decimal numbers.
Sorry.
And here, yeah, I try. And he also had on this website, or he has on this website, the feature that you can encode these two geonames, these two-dimensional geo coordinates into a one-dimensional, so to say, hash string of 11 characters. And the presenter also told about a Hilbert curve, which was. Hey, you're binding me. He also told about the Hilbert curve he used for this mapping or for this conversation to reduce the borders. Now he's also taking me away the.
I'm sorry.
The text. Yeah, no, it's okay. You just have to do your work.
Yeah, just need to make.
I'm only here for fun.
Yeah.
Well, I've already used it to watch TV and stuff like that.
Okay, I'm gonna get the go-kart on your table. back to me.
Okay, let's see.
That's a really
Okay, so what I did then after, because I found the idea rather interesting, was I analyzed the website and I had a closer look at it, so to say, and I saw that the mapping really works in both directions. You can enter geocoordinates and get the word combination or back. I already told you that there's an API which you can use. There's a link to the source code, which is also appreciable in terms of open source. There's also a map in the user interface, but it's rather small. It's improvable, so to say, and also the user interface around it is also improvable. So I had a closer look at the code. It has been written in Perl. It's the code is working as expected, but it's not easily readable. Then in the code there are some obstacles, so to say, or almost obstacles. It's tweakable because some big integer representation is used, so for arbitrary size integers which are not needed. There's a bit shuffling code in it, which is done in the most standard way, which is heavily tunable. And also the hashes I told you about. This 11 letter string is done of, or it consists of 26 characters, all alphabetic characters, and the 10 digits. There are other representation which only use 32 characters and digits per letter to make it to avoid some rude words which you might create with such a mechanism. So so to say, this 3geonames.org website represents a very good idea. It works, but it's still improvable in terms of UI and also coding style. And I would say it's maybe in the area of 50% if you use this Hilbert's this Edison scale, as I called it. But then there was the idea of the Hilbert curve, and this now was the 1% inspiration for me, because when you do some research on it, then you find out you could do the following. You could just take one Hilbert curve, or take several, take 4 of them, connect them to a cyclic Moore curve, put them on the map. You can use for the whole world. You can use this level 0 OSM's tile with the Mercator mapping, with the Mercator projection. Then what you can do is that you can take a point on this map, map it to the distance it has on this curve from a fixed origin you have to define. And then if you have several points, you can map all of them, and you can sort them according to this distance on the curve. And the result is that this order you find is an approximation to the traveling salesman problem. It's a rather reasonable, not optimal, but reasonable route you find. This has already been studied in the past. You find examples where Meals on Wheels have been using it, and they really improved their driving times with that. You can also use it again for packet delivery, for geocaching, or for home care, wherever you have to visit many positions. So imagine that you use this system as an addressing system for postal services. You simply have this. You give it this unique address, and the postman simply has to sort his letters according to this index and travels them, and well, he can do it rather fast. So regarding the perspiration, as I said, I'm more on this 1% side. Yeah, what I did or what I'm working on now is another proof of concept. I would like to make it a complete system, but as I said, I don't have the perspiration on the one hand, and since it's only a hobby, I can't find the time for that. And there's even more inspiration just to improve the user interface. Regarding the routing, this TSP approximation only is according to the distance on the map. If you have small areas, then you get no or almost no distortion on a Mercator projection. And you get good results, but you can also use, or you can further improve the result if you use routing algorithms according to or using the roads and highways. And you can also use the result as an input for other optimization or algorithms like the two-opt algorithm, which run much faster than before. They don't give better results, but they finish much earlier. Yeah, basically that was everything I wanted to tell you without
Well,
this.
maybe we could make a little bridge. What is your question to the room?
My question to the room. Could you imagine to use such a system which very easily gives you a short round-trip route for whatever purpose? As I already said, geocaching, if you want to find 10 caches on a day or so, then you have to, well, if you're visiting a foreign place, or for instance, if you get to Brussels, you find several 10 geocaches on the map, and then have to order them according to your have to find the visit order. So that's what I wanted to say. Something like that. Or if you know someone who does home care or works for DPD or is a recharger, e-scooter recharger.
Well, the room. Anybody interested in this or could see somewhere an interest? Is there anybody? Yeah.
Yeah, I work at the airport in Schiphol.
Sorry, could you?
Yeah, sorry. I work at the Amsterdam airport.
Yep.
I work actually with indoor wayfinding, so I have to walk indoors, and we have a lot of contractors that need to go through different rooms in the airport. It's quite interesting because they need to go through security filters and other things to go somewhere a place, and then they need to get out and they go to other places. And actually, super big
I'm
building,
finished now, so I don't need it anymore. But
Are you doing anything about the
best route to walk through all the
sorry, I have to just to listen to you.
So actually,
Okay.
yes, but then we have like more logic with how you cross security filters indoor at the airport.
Yeah, but then even this algorithm I just presented, it could help you if you put another algorithm on it, which also considers the waiting times at the security filters, to quickly get a result, because those algorithms, if you have 10 or several 10 locations, they have immense run times. They are rather slow because this traveling salesman problem is one of the most complicated or most complex solvable problems in computer science. It could help, yes.
Would a conversation at another time, another place be worthwhile for the two of you?
Yeah, I think so.
Well,
Yeah,
at
well,
least
you
have something out of
Yeah.
this meeting that I think will work for you. Is there anybody else who has a question to Yeah.
Yeah, it's such a bummer with the screen, so I thought maybe it would be nice that if anyone's interested, Stickle, we could perhaps point us or those people to any online resources which might have a trace of what
Yeah.
you said, and then we could find
So these addresses, you can have a look, but they are also at the currently at a low level of implementation. But well, not really, because they are doing this Hilbert optimization, and then you can't stop it before that. They are doing a 2-opt optimization to find even shorter route. So.
Right. Unfortunately, you have not been able to show your algorithms like last year.
Yeah.
On the other hand, it sort of flew at the top of my head, but I'm not a mathematician.
Okay.